What up, mathletes? Whoop, whoop. All right, welcome to 3.4. Our learning target today is I will use SSS and SAS. That's side, 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 and side, ankle, side similarity. So not the congruency, but similarity theorems to solve problems and prove triangles are similar. Take a minute, do the warm-up, we'll talk. I'm assuming you're pausing it right now while I drink coffee. Boom, let's look at this. Are the triangles similar? Justify your answer. I would say for one, yeah, these are all the same size and these are all the same size, and that means the only way that happens if all these angles are the same. So these are all going to be 60, 60, 60, which makes these 60, 60, 60. So yes, they're all going to have matching angles, right? In fact, they're all going to be the same angle, which makes them similar. Okay, right here, see it says 53 degrees right there, that's 90, so to get this last angle right here is going to be 90 minus 53, which is what, 37? So that's going to be 37 degrees. And right here is 37 degrees and 90, so we know this is going to be 53 degrees. So again, we have angle, angle, angle. But I could look at their sides as well. 5 is the hypotenuse, corresponds with 10. 5 over 10 is 1/2. 3 corresponds to 6. 3 over 6 equals 1/2. And then 4 corresponds to 8. And 4 over 8 equals 1/2. Same ratio there, so yes, both are similar. Yes, both are similar. Are the triangles congruent? Well, we have a matching side angle and included side, side included angle and side included angle and side. Yes, by side angle side. And this one right here, side corresponds to side, second side corresponds to second side, third side, yep. Yes, by side, side, side. Boom! All right, you've kind of been seeing it right here, but take a minute. Go ahead and write down, in fact, I'll give you the full version, right? It looks a little bit prettier over here. If the corresponding sides, lengths of two triangles, are proportional, then the triangles are similar. In other words, sides are proportional, then triangle JKL is similar to triangle NPQ. Pause this, write it down. I'm moving on to the next one. And the side angle side similarity. So these are like the congruencies, but they're similarity. This says, if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, so that angle in between them. So in other words, I know that RS is proportional to XY right here. Let me see it all the way. Here, let's make this bigger then. You can see the whole thing at one time. So RS is proportional to SY, and ST is proportional to YZ. The included angle, S is congruent to angle Y, then we know by side angle, included angle side, that triangle RST is similar to triangle XYZ. Boom. Again, pause this, write it down. We're going right back to our regularly scheduled program. Okay, you'll see I have them written down. Boom. Let's look down here. So let's do this. We're going to work on side, side, side. So I know that JL is 12. I know that QM is 9. 3 goes into both of those. 3 goes into 12 4 times. 8 goes into 9 3 times. Okay. LK. LK is 8. MP is 6. What goes into both 8 and 6? 2 does. 2 goes into there 4 times. 2 goes into 6 3 times. Boom. And last but not least, let's look at JK, which is 16. And QP, which is 12. And I know that 4 goes into 16 4 times, 4 goes into 12 3 times. Those are all the same. Therefore, by side, side, side similarity, triangle JLK is similar to triangle QMP. Look at that. Boom. All right, let's take a look at the back. Don't We're going to run through slides on that one. All right, let's look at this one. We're going to do our side angle side on this bad boy right here. Okay, so show that the overlapping triangles are similar. Okay, so I got to do the two sides. So first of all, this entire thing right here is 5. This one is 3. So AC over AB. Let's do AC over AB, which equals 5 over 3. Okay. And now I'm going to go ahead and say that simplifies to, you know what? I'm going to switch that around. Let's do AB over AC. I have a reason for doing this. It's going to be 3 over 5, which equals 0.6. It just comes out without rounding. And then I'm going to do the small one right here, which is 4.5, or AE over AD, which equals 4.5 over 7.5. 7.5 because I got to add these two together. Let's confirm this on a calculator. 4.5 divided by 7.5. What does that equal? 0.6. Look at that. Now I just need to know. So I've got this side, right, figured out, and I've got this side figured out. I need the included angle. Well, we know angle A is congruent to angle A by the reflexive property. Therefore, triangle ACD is similar to triangle A. I always use that triangle and I make it into the A, right? Triangle ACD is similar to triangle ABE. Boom. Now find BE and the measure of angle CDA. Let's see. Well, first of all, if this is 42 degrees, I know this is 42 degrees as well. So I know that the measure of angle CDA, so that's CDA, that's right here, equals the measure of angle BEA, which equals 42 degrees. So that one's easy. Now, these sides should be proportional. So I'm going to say x over x plus 14, right? Because it's that BE over CD should equal either one of these. Let's just do AB over AC, which is 3 over 5. We're going to cross multiply, and I get 5x. And remember, I'm going to distribute this when I multiply, equals 3x plus, and 3 times 14 is 30, and 12, 42. Let's subtract that 3x over. We'll get that 2x equals 42. Divide by 2, and we get that x equals 21. Boom! So BE, and BE equals x, so this is 21. I was looking at this thing, and this looks really big, then I realized that's 1.4. That's 1.4, which would make this 4.2, which would make this 2.1, right? Don't get mad at me, people. This is 2.1. I was like, something's off there, but there we go, 2.1. I was just missing a point. Decimals matter. All right, this last one, guys, we're actually going to take a look at some slides. So let's go to the slides. Ooh. And don't freak out. You're going to have some time to write stuff down, but you're going to need to write stuff down on the drawing I gave you. So Julia is designing an A-frame house. The entire house will be 40 feet tall, and the base of the house will be 60 feet long. She will build a second-floor balcony along the front of the house, 15 feet above the ground. The left side of the house will be 50 feet long, and the balcony will intersect the side 18.75 feet from the bottom. The peak of the house is directly above the midpoint of the base. So in other words, that peak cuts this base in half, right? The midpoint of the house balcony, calculate the total length of the balcony. We want the length of this balcony. Well, here's what we're going to do. This may look confusing, but let's draw what it says. The height of the house is 40 feet. So 40 feet from the midpoint up to there, which cuts it into two equal triangles. The base of the house is 60 feet long. So this base is 60 feet, which means half the base is 30. The balcony is 15 feet above the ground. So the distance from here to here is 15 feet, making the distance from here to here 25, because 40 minus 15 is 25. The left side of the house is 50 feet long. So that's the left side. That's from here, boom, up to here. That slant height is 50 feet. So it's the hypotenuse of this triangle. The balcony intersects the sides of the house 18.75 feet from the bottom, which means if this is 18.75 feet, then up here we've got what? 31.25 feet for this hypotenuse. Sounds like we have two similar triangles. We have this large triangle right here. Let me show you kind of. We have this large triangle right here. But then we have this smaller one right here. Okay? So it looks like we're going to look at those two triangles. All right. Let's do that. Let's go through the slide. So if I call this A, B, C, and this is A, D, E, let's create two triangles side by side. Oh, I gotta get rid of this. A, B, C, A, D, E. Look at what we know. We know this is 50, 40, 30, and this one we know is 31.25 and 25 by subtracting, but we don't know ED, which is half the length of the balcony. Okay? And what do? We know there's similar triangles, though. AC, or at least we're going to prove it, AC over AE is 50 over 31.25, which is 1.6. Go ahead and write that down. Calculate it. Write this down. AB over AD equals 40 over 25, or 1.6. Those are similar, and they both share angle A, which we already did in the last problem. We know they're congruent by the reflexive property. Therefore, this has side, included angle, and side similarity. Boosh. They're similar. We can set up a nice ratio. We're just going to say 50 over 31.25 equals 30 feet over ED, or X, however you want to call it. And then we calculate that our ED is 18.75 feet. Here's the deal. The height of the triangle bisects the length of the balcony, so the total length of the balcony is actually 2 times that, which is 37.5 feet in total. Boom, that's a good problem. I'm going to show you how I wrote it out on mine, guys. But I got to shoot this down. You can see this down here. Have it all labeled once you see it. Boom. So you guys can see everything there. Okay, feel free to pause this, to copy it down, however you want to do it. This is how I showed my work. With that said, peace out.